Jai Hind. My name is Vaishali Deshwal, and currently I'm working as an assistant professor at APGEC, Ghaziabad. Today is the fifth lecture on artificial intelligence, and today's topic is natural language processing. So, let's start with the definition. So, NLP, it stands for natural language processing. It refers to the branch of computer science, and most specifically the branch of AI. So it is concerned with giving the computers the ability to understand the text and the spoken words in a similar way as the human beings can. And it derives the computer program that can translate the text from one language to the another, respond to the spoken commands, and summarize the large volumes of text rapidly in even in the real time. So there are some terminologies. For example, machine translation comes under the NLP, and what does it mean? It refers as a subfield of computational linguistics that investigates the use of softwares to translate the text or speech from one language to another. So this is the machine translation, or we can say which is used to translate the text from one language to other. So on the basic level, it performs a simple substitution of the words in one language for words in another. For example, if I want to convert any sentence from English to French, so there will be the word substitution, the simple word substitution there will be. So, but that alone usually cannot produce a good translation of a text, because the recognition of the whole phrases and their closest counterparts in the target language is needed. So, the recognition of the whole phrases and the closest counterpart. So, the recognition of these things is very important. Alone, the substitution of the word doesn't suffice. Next thing is that solving this problem with the corpus statistical and the neural techniques is a rapidly growing field in this, that is leading to better translations, handling the differences in linguistic topology, translation of idioms, and the isolation of anomalies. So to solve this problem with the corpus statistical, this field is quite important. Next subtopic in NLP is machine translation. So we have already studied that what is the definition of machine translation and what MT refers to. So now we are going to see this particular term in detail. So MT, or machine translation, is the automatic translation of text from one natural language to another, means from the source to the target, and that is the machine translation in very simple or the basic terms. The translation is very difficult, and it requires in-depth understanding of the language. A translator, it can be a human, it can be a machine, and it often needs to understand the actual situation which is described in the source, not just the individual words. Sometimes the words, they're saying something else and the situation is something else. So the words, they are used in what context. It is very important to understand that context, that okay, these sequence of the words, they are used in these particular sequences. For example, if we are just considering the word open, so this is a sentence, this is the first sentence, as you can see here, that open on the door of a store. So it communicates the idea that the store is accepting the customers at that particular moment. And that is where the statement is, that open on the door of a store. So it's an example that a particular word, open, is used in the two different sentences, but it conveys the different meaning. So in the first one, it communicates the idea that the store is accepting the customer at the particular moment. And now consider the same word open, but in the other sequence of the word. That is open on a large banner outside a newly constructed store. So it means that the store is now in daily operation. But the reader of this sign, they wouldn't feel misled if the store closed at night without removing the banner. So there are two words, but they signifies the different meanings. So the signs, they use the identical word to convey the different meaning. So it is very indispensable to understand the context in what context the words they're written there, or what a particular sentence is try to convey. Now there are three main applications of MT, or you can say machine translations, and these are rough translation, pre-edited translation, and restricted source translation. So rough translation is as provided by the free online services, that is the gist of the foreign sentences or the documents, but contains the errors. Pre-edited translation, it used by the companies to publish their documentation and the sales materials in the multiple languages. And the third application of the MT is restricted source translation, that works fully automatically but only on highly predictable language such as weather reports. Next, so again, there are two systems. First is MT system and second is statistical machine translation. Now the first is machine translation system. So all the translation system, they must model the source and the target language. The target language is the one in which I or anyone want to convert the language to. Some systems, they attempt to analyze the source language text all the way into a interlingual knowledge representation, and then generate the sentences in target language from that representation. So these are the steps in the MT systems. Firstly, one has to just analyze the source language text all the way, and secondly, it has to generate the text in the target language. So there is a source language, there is a target language. For example, if someone wanna convert a sentence in English to a sentence in French, so English sentence is a source language, or or we can say it's a source text, and we want to convert it into the target language, that's a French language. So these are the two steps in this. Then it is very difficult because it involves the three unsolved problems. And what are these? First problem is that creating a complete knowledge representation of everything. We have to just represent everything, create the complete knowledge representation of everything, and then only we can be able to do the translation. And the second thing is parsing into that representation. So first we need the representation, secondly we need the parsing, and third we generate the sentences from that representation. So we should be able to generate the sentences from that representation. So these are the main difficulties while we are just building or creating the MT systems. Next we have the machine. This is a continuation of MT systems. So it keeps a database of the translation rules. For examples, the translation rules, they can be the examples. For example, like in one sentence, if there is a word and like is, and there is another word which is used for is, so this is the example, this is the rule set, and the data set of such rules is kept, and whenever the rule or the examples matches, they translate directly. So transfer can occur at the lexical, syntactic, and semantic level. So these are the levels on which the transfer can occur, and this is called the transfer model, and it comes under the machine translation systems. So let us see an example. For example, transfer the English to French. So English language is a source language and French language is a target language. Look, you need to understand that what is the source in the and what is the target language. So for example, a strictly syntactic rule maps. So here, as you can see, English adjective noun to French noun adjective. What does it mean? It means that if in English we are writing adjective noun, then in French we have to write noun and adjective. You need to just understand the order, that in English we are writing adjective and then noun, and in French we are just writing noun first and then adjective. So this is the syntactic rule, and this is how the syntactic rule maps. Then a mixed syntactic and the lexical rule maps. For example, French S1, it use S2 to English S1 and then S2. Means ET, for ET we are using and And for PUIS, we are using then in English sentence. So these are just the substitution of the words. Now, this is a diagram, and this is called a triangle, a symmetric diagram of the choices for the MT system for John loves Mary. So John loves Mary, it's a sentence, and it's a English and it's an English language, or you can say these are English words. So these are the levels here. Firstly, we are just converting these English words to the English syntax, and then English semantic, and then interlingua semantic, and then French semantic, and then French syntax, and then French word. So these are the levels, and we are just going in this way. We are just following these steps in this way. Firstly, this is a John loves Mary. So we have to convert this word in this representation, that is called English syntax, and then we have to convert this into this relationship here. We are writing loves John Mary. It means John loves Mary. John loves is a relationship. So we write loves and then bracket John, comma Mary. So this is the English semantic, and then we go to the interlingua semantic, and again we come here, and finally we get the word in French, or we get the French words. So start with the English text at the top, and the interlingua based system follow the solid lines. As you can see here, these are the solid lines. So follow these solid lines, parsing English first into a syntactic form. As you can see here, syntactic form, and then the semantic representation we have to create, and then interlingua representation. And when we reach to the interlingua representation of the English word, which we want to convert it into the French language, then through generation to a semantic, synthetic, and lexical form in French, we are able to convert it. Okay. So the transfer-based system uses the dashed line as a shortcut. So instead of just using these solid line, the transfer systems is using these dashed lines as a shortcut. Means for that these are the words in French for these words in English. Okay, so the different systems, they make the transfer at the different points, and some make it at the multiple points. So this is the basic semantic diagram. Next, we have statistical machine translation. So we have seen the machine translation systems and what are the steps involved in it, what are the difficulties which are involved in the machine translation systems, and now we are going to see statistical machine translation. So let's start. Let's suppose that there is an English sentence and E. Finding a French translation F. So English sentence is E, it is represented by E, and then the French, we want to find a French translation, that is F. So it's a matter of the 3 steps. First, we have to break the English sentence into the phrases, that is E1 to En, and then for each phrase, EI, we have to choose a corresponding French phrase, that is FI. And then we use the notation, that is P, FI, EI. What does it mean? It's a conditional probability for the phrasal probability that FI is a translation of EI. So it's look like conditional probability, and you can just understand by this particular notation that FI is a translation of EI. And then in the third one, you have to choose a permutation of the phrase, that is F1 to Fn. So these are the 3 steps which you need to follow in order to have a conversion or the translation from the English sentence to the French. So for each FI, we choose a distortion, DI. So DI is, we are using the symbol DI for distortion. And what is distortion? Distortion is the misrepresentation, which is the number of words that phrase FI has moved with respect to FI minus 1. So we're going to see an example here, and by that example you will be more clear about it, that what is distortion, what is minus 1, what is plus 1, what we are doing actually. So for misrepresentation, there are certain rules, and the rules are like that for the positive we are moving to the right. So if we are moving to the right, then we are going to assign some positive number. And if we are going to the left, then we are going to assign some negative number. And 0 if the fi is immediately following the fi minus 1. So there are the three values, positive, negative, and the 0. And if the word is shifted right, then we are going to assign positive. If the word is shifted left, then we are going to assign negative. And if it immediately follows the fi minus 1, then we put 0, or there will be no shift. Okay, so this is a concept of distortion, that is represented by di, and that stands for misrepresentation. Okay, so here is the procedure, that this is the procedure for statistical machine translation. If we want to convert any sentence from any language to any other language, then we need to follow a procedure, and these are certain steps. So total there are 6 steps. First is that we have to find out the parallel text. Suppose I'm having a sentence in English language, I have to find out a parallel text in, and suppose the target language is the French. So firstly, I have to find out the parallel text in the French one. Now, second is the segment into the sentences. Means the unit of the translation is a sentence. So we'll have to break the corpus into the sentences, because the unit of the translation is the sentence, and that is the reason that we are breaking the corpus into the sentences. So periods are the strong indicators of the end of the sentence, and third step is that we have to align the sentences. So second is segmentation. Third is the alignment. For each sentence in English version, determine what sentence it corresponds to in the French version. And fourth one is align phrases. That within a sentence there are certain phrases and they can be aligned by a process that is very much similar to that used for sentence alignment. So we are going to do 2 alignments here. First is the sentence alignment, and second is the phrase alignment. And then we have to find out the misrepresentation, that is the distortion, or you can say D. So expect the distortion. So count how often the distortion occur in the corpus for each distance. It can be which can be represented by the values. It can be 0 if there is no movement. It can be +1. It can be -1. So the value can be positive, negative, or the 0 based on the movement or the distortion. And then we have to apply the smoothing to correct that. Sixth is improve the estimates with EM. EM is expectation maximization. It's an algorithm. So we have to improve the estimate with it. Used to improve the estimate of PF by E and PD values. Okay. So as you have studied that, what does it mean? PFI by EI. It's for the phrasal probability that FI is a translation of EI, and FI is a French phrase, and EI is the English sentence. Okay, so E step is, that is the expectation step, is that compute the best alignment with the current values of these parameters. And the second is M step, that we have to update the estimates and iterate the process until convergence. So this is a simple example, and in this we are just following the procedure. As you can see here that this word is moving this side. So we are assigning -2, and this word, as there is no change here, so we are just giving it 0, and still there is no change here, then we are giving it 0 value. So this is a sentence in English, this is a sentence in French, and we just want to convert this sentence into the French language. So if there is a movement, if we move right, then we assign some positive value. If we move left, then if there is a movement of the word to the left, then we assign some negative value. And as for example here, and if there is no movement, then we assign the D value as 0, because there is no movement, the distortion is 0. So the procedure is that you have to find out the parallel text. Second is segment into the sentences. Third is align the sentence, align the phrase, and then extract the distortion, the D or the misrepresentation value, and then improve the estimate with EM, means the expectation maximization steps you have to follow it to improve the estimates.